next-generation data-centric workflows that combine simulation, data analytics, and AI. When you hear the statement, your ears are perked up. Intel has been building an entirely open-source software ecosystem for data-centric computing, and here to speak about innovating distributed storage design with DAOS software stack and Intel persistent memory is Andrei Kudryavtsev, HPC storage solution architect at the DAOS product manager from our platinum sponsors, Intel Corporation. Over to you, Andrei.
Thank you very much. Great introduction, and happy to be here presenting at this event. So my name is Andrei Kudryavtsev. I'm product manager. I'll be hosting this 15-minute keynote talking about DAOS, what we are doing in this domain, and what this product is about. I understand it's just another acronym in the first place. It's not the word by itself. DAOS stands for Distributed Asynchronous Object Storage. And this is a software product that Intel has started developing over 8 years ago. And we had that problem identified way long time before actually we had the hardware to support the software design that we proposed. So DAOS design is, first of all, it's a storage. It's not a file system in a standard definition of a file system. It can be your file system, but it's significantly more than just a file system. I can easily explain this as very high performance key value storage, and this is what actually underneath the DAOS is. It's a key value store, which is optimized for the latest hardware generations of the two primary technologies. One of these technology is a flash SSDs based on the NVMe, NVM Express protocol. So that's a standard PCI Express SSDs, which are now part of every server design. And the second technology, which is used for DAOS functioning, is Intel persistent memory. And this is a block addressable DIMM form factor memory module that goes into the memory slot of the server, and which provides the memory expansion and persistency. The reason why we need two of these technologies functioning at the same time in the DAOS design is because we run in it for different purpose. So all the small I/O and metadata operations, such as metadata updates when you're creating the million files, they go into persistent memory because this is actually the product to support these sort of I/O operations. It's highly efficient, it's a cache line addressable, and it's persistent. That's exactly what we need for metadata performance. The second product that actually stores the data is NVMe SSDs. And this is where it's coming the bulk of your capacity. And this is where we want to make sure that this capacity provided you at affordable cost, so you can store lots of the data inside system. DAOS is a distributed storage. So that design leveraging Intel Optane persistent memory and NVMe SSD is the part of the design of every DAOS system in the solution. There is no metadata servers, there is no specific head node servers. All servers designed in a way where they really combine these two products together and they balance the load between these systems. That's a part of a fundamental design of this on the hardware side. On the software, this is actually where the whole innovation is happening, because you have two highest performance hardware technologies underneath. Then you have a DAOS engine, which talks to these technologies through the user space. So that's the most efficient way to communicate to your hardware using user space libraries for NVMe. That's called SPDK. That's another Intel library that Intel is providing for NVMe communication. And for persistent memory communication, it uses the library called PMDK. So having two of these and having whole DAOS engine running in the user space allows us to do really efficient I/O transactions from the operating system standpoint. But the main innovation is happening where how you attach the DAOS to your data. And even underneath, it's a key value store, as I mentioned already. You have a whole variety of different protocols and interfaces. We call it middleware, how we provide the access to the data. And let me give you simple examples. For many DAOS users who just install DAOS for the first place, for them the most easiest and affordable way would be using DAOS through the POSIX interface, because in that case, DAOS can emulate itself as a file system and provide the POSIX access to the files, directories in a normal way how you would do that. And so you don't require any changes for applications. You don't require changes in your infrastructure, you can use your existing applications to interface to DAOs and leverage the fastest performance of the persistent memory and NVMe SSDs. But this is not it. This is just, let's say, the way how you interface your existing applications. We also have specific middleware to address some of other interfaces, such as for HPC-specific, HDF5 and MPI I/O are another two common ways how you would interface to the I/O. For big data specific, especially for high-performance data analytics, DAOs can emulate Hadoop distributed file system, HDFS, by just providing the same interface and being able to leverage the Spark and Hadoop and attach to DAOs natively without any changes to those by just emulating HDFS interface. We also do integration with the development languages, and here the example I want to bring is the Python library. So for the Python developer, we provide the DAOs Python library, which allows to speak in the data domain to the storage. So it's no longer files, and you don't need to do a file I/O. Instead of that, you do load, store, load, retrieve, like how you would do that with the standard Python programming. And that would be absolutely transparent for the Python applications. And of course, you will leverage the highest performance of DAOs. In addition to that, we provide the native DAOs interface for the DAOs API, which is a basically key value interface. And there's a whole set of applications which already adopted this interface. And here I just listed several of those. On the right side is just examples of how customers already take the DAOs development and integrate it together with the very codes, such as with some specific sensor databases for HPC customers. I have several examples here, FDB and root and DAQ, or some specific codes like another customers in oil and gas, for instance, do the seismic data processing. They also load it directly to the DAOs and speak to the native DAOs interface. That gives them the ability to consider DAOs not being really a file system. For them, it's an application store. This is where you can take your data set and put it in the format of your data set. You don't need to translate it to files. You don't do any translation to blocks, and you walk away from this. You just store it in the format where it was the original format of the data. This is what makes really DAOs interesting. And the DAOs in that case is a storage. It's a standalone storage. It doesn't require anything that it's needed in addition to DAOs to start operating. So it's not something like a burst buffer, and it's not the I/O nodes and the standard things of that. Actually, DAOs is a standalone storage, but we certainly see the ways how you can integrate DAOs together with other file systems in the same environment. So that provides the best of two worlds. DAOs is certainly the performance per dollar optimized. So that's the most I/O efficient usage of the hardware technologies in the DAOs configuration, while you still decide that you want to extend the capacity by using low-cost storage technologies. For instance, you want to extend DAOs capacity by migrating data between some other existing distributed file systems. Here are some examples here. In HPC environment, we typically do that with Lustra. This is, of course, very known file system for HPC and for some big data systems as well. But technically, it can be any other POSIX compliant file system where you can take the DAOs, where you can take the mechanism which is built into the DAOs for data migration. It's called data mover, and move the data between the DAOs and other file system on a demand. So for instance, you did some processing of your data inside DAOs, and then you decided that you want to move that data outside. And it's very straightforward to do between the POSIX DAOs container and between the POSIX compliant file system, such as could be IBM Spectrum Scale, such as could be Ceph, any NFS storage, or any other POSIX compliant file system. Of course, in addition to that, we put some specific attention how we can expand DAOs into the cloud capacity using object interfaces, and that is also in the possibility how users can migrate the DAOs between these two. So that is very new, and we certainly at Intel, we believe that for users, it's very important to provide the best of many words and create a tiered file system design. There is no single file system that leads in everything. Well, we know that some leading is really in a massive capacity. You can create tons of capacity with Ceph, being challenged with the performance for some applications. And this is where you can create on top of a Ceph the DAOS layer and provide that missing performance, close that gap to your application performance, and move the data between DAOS and Ceph, for instance, like an example. And this is actually what our customers deploying right now. They take multiple file systems design in their cluster and they combine it together for the most of advantage. DAOS is open source product. This means there is no any charge associated with this product. You can go to the main DAOS website, daos.io. I'll be talking about that later. Download it. It's available as precompiled binaries, as well as it's available as a source code, and use it yourself. You can rely on the DAOS community for the support. You can talk to our developers. We are available through multiple channels. I'll be talking about that also later. But there is also the DAOS roadmap that actually says how we're developing this product, how we're introducing one feature after another feature. And with these terms, we already at the DAOS 1.2 revision, we launched 1.0 last year. There was a massive introduction for the first production release of the DAOS. This year, we launched 1.2 and launching 2.0 later this year. And the idea that we gradually introducing the features to the storage. And as such as one of the most demanded feature was previously the ability to do erasure coding for the data. And we introduced it as a preview for this current release. We will be fully launching that in the production for 2.0 release. And that's typically how DAOS development is structured. Some of features available earlier for you, so you can go and put yourself for the test and enable these and provide us with the feedback that we're really eager to learn. And in the meantime, some other features would be getting ready to this and launched later in the production releases. That's how it works. And there are some binaries associated. So for every of that major revision release, we have binaries available. Today we do that for CentOS 7. We do that for CentOS 8 branches. I'm not specifically saying CentOS 8. That's certainly multiple ways to do that with the recent changes in the Linux ecosystem, considering, of course, Rocky Linux, considering Alma Linux, and others, how we continue that. But that's the main thing, and we will continue introducing these features and operating support later for others. But in general, that is how the roadmap split. All of that is available for you in real time. As I said, the main repository for DAOS is on GitHub. You can log in there and you can take either the latest snapshot or you can take the latest stable codes with the binaries available. So there are many things in the places here. And being an open source program from Intel, DAOS is expanding into the partner program as well. So what it means? That basically means that we're working closely with partners to provide the full turnkey solution for the DAOS, let's say, appliance level solutions. This is where you go to a partner and order not just a hardware, you order a fully pre-configured, recommended configuration running DAOS. And several weeks ago at International Supercomputing, just 2 weeks ago, we introduced the Intel commercial support for DAOS. So for customers who do require somebody standing for the support and providing the support based on SLAs, they can now rely on Intel. Intel is providing level 3 commercial support. And one of our partners, they providing level 1 and level 2 commercial supports. So working together really helps us to build this ecosystem and making sure that, well, customers can really rely on the DAOS support and benefit of DAOS being an open source project. not everybody needs a commercial support. We certainly see the users who do not need it, then they have their own resources, or then they do some research activities. Certainly they can able to do that themselves. But for traditional users in commercial businesses, in enterprise businesses, they certainly looking for the companies standing for the commercial support, and that's what Intel provides now. So that was a really quick overview of what DAOS is. It's very big project, and it's very interesting project for Intel. It's driving the changes in the storage, in a way how you consume storage. I highly encourage you to learn more about this at daos.io. This is the main website, and from there you will get the links to the GitHub with all the source codes available. You will get the links to our documentation, including admin documentation and including the development documentation. I encourage you to join our mailing list at groups.io, so you'll be all up to speed with the latest changes and updates there. And of course, as soon as you join the mailing list, you will also get the invitation to the DAOS Slack channel. And this is where you can talk in real time to any of us, to any of the DAOS 50 developers, and we will be happy to help you solving the problems during the installation and help you with the migration of your codes and so on. So thank you for giving me time to speak about this today, and hope to see you at DAOS portal.
Thank you very much, Andre. That was a very quick but very in-depth view on DAOS, and we're very glad to be working with you. So hopefully we get to do a lot more collaborative work in this coming future.
Absolutely. Thank you very much.
Yeah. If you do have any questions on this session, please feel free to post them in the Q&A. We will try to take them up now, or we will get them answered later and probably share the answers with you over our various public channels. With that, we come to an end in this session. Thank you so much, Andre, and thank you for attending all these sessions. Let's now move on to the next session, that is a keynote, which is going to be by Sam Werner, and we can connect into that session. So let's move on to the next session in Hamid. Thank you so much.
All the best. Goodbye.